Well, in this section, we're going to talk more about slope, and we will learn a few new terms, and then we'll review some terms that I'm quite certain you know from an earlier math class. Well, the first one you probably already know. If two distinct non-vertical lines have the same slope, then the two lines are blank. I bet you got this, parallel. And similarly, only a different type of line. If two distinct lines both have undefined slope, then the two lines are parallel as well. You may not have seen the definition of parallel broken into two pieces before, but in mathematics, we're very precise. Let's look at the first one. Why is the word distinct there? That is because if two linear equations have the same solution, they're equivalent, which means if you graph them, it would be the same line. If two lines are the same line, we don't consider them parallel. So they have to be distinct. They have to be at least slightly different. And they're stating here non-vertical because non-vertical lines have a slope m with a numeric value. So it's easy to compare the two numbers. In this case, we still need distinct, two different lines. If they both have undefined slope, then they're parallel. Why don't we just say they have the same slope, or the slopes are equal? Well, you really can't compare two things that are undefined by saying that they are equal to each other. So this, again, is a technicality, but I'm just being very, very specific here. Okay, parallel lines. The next, number 2 says, what is the equation of the line that passes through this point, 4, -1, and it's parallel to this? This is the equation of a line. So what do? How can we use knowledge we've gained to come up with the equation of the line? Well, we do have a point here. So if we had another point, or maybe the slope that we need, we could use the point-slope formula. And what does parallel to this line mean? All that it means is it has to have the same slope. So what is the slope of this line? Y equals mx plus b. It's -3. M equals -3. Now this is a problem just like in the previous section. We have a point and we have the slope. So we take I'll write this equation down one more time. Y minus y1 equals m times x minus x1, where x1, y1 is this point here, x1, y1, and m is the slope. So we get y minus -1 is y plus 1 equals the slope m is -3 times x minus 4. Now, from now on, on most of the problems we do, I'm going to want this to be written in slope-intercept form. So maybe I'll start right now. Let's write this in slope-intercept form. Normally it'll say write the result in slope-intercept. So this is the same as y plus 1 equals -3x plus 12. So hopefully you see what I did there. I distributed -3 times x, -3 times -4. Okay, subtract 1 and we're done from both sides. So y equals, that 1 goes away, -3x, and we're subtracting 1, so I get plus 11. This is the line written in slope-intercept form. That is parallel to this one, obviously, because this has a slope of -3, and this has a slope of -3. And it passes through 4, -1. And if you wanted to be very, very careful and check your answer, y is a -1, so -1 equals, let's verify this. X is a 4. -3 times 4 is -12. -12 plus 11 gives me -1. So we are correct. All right, now another term that you probably remember is the following. Two lines that intersect at a right angle, that means they intersect at 90 degrees, kind of like a plus sign, are called perpendicular. Okay, now there's some textbooks will define the two lines being perpendicular based on this next thing we're going to state. You may not have seen this before. The product of the slopes of two perpendicular lines is equal to blank. Well, if it's always the same number, one way we could come up with that number is write two parallel lines. I'm going to go up here a little bit. And I haven't written the XY axis, but can you tell which line this is? Or the slope of that line? I'm intending it to make like a 45-degree angle, so it would have a slope of 1, up 1 over 1, up 1 over 1. And then that. Well, it's the slope of this line. That would be a down 1 to the right one, down 1 to the right one. So this, I'll say M1 equals 1, M2 equals negative 1. And I'll point to the lines that they're referring to. So again, I need to make sure it's obvious that this picture is going with number 3A. So those are perpendicular lines. What do you get if you multiply them? Negative 1 times 1, negative 1. Simple as that. In other words, another way we could state that is, what kind of numbers do you multiply together to get positive 1? Think of them as fractions. Well, I'll give you an example. 2 over 3 times 3 over 2 is equal to 1. When you multiply reciprocals together, you get 1. So what we're calling this, the slopes are negative or opposite reciprocals of each other. Okay, so let me make that example here. There we go. So if one line has a slope of 2/3 and the other one has a slope of negative 2/3, they would be perpendicular lines, because when the product means you multiply, you get negative 6 over 6, or you could just cancel the 3's, cancel the 2's, leaves you with negative 1 equals negative 1. All right, so this is just a very simple review. Two lines with the following slopes are perpendicular. So what I want here is 1, 2, 3, 4 pairs of perpendicular line slopes. 2. So what would the other slope be if the two lines are perpendicular? One of them has slope 2. Well, 2, remember, is 2 over 1. So the reciprocal is 1 over 2, and one of them has to be negative. Negative 4/5. Well, that has, the reciprocal is negative 5 over 4, but we have to take the opposite sign, the negative reciprocal, and now we have two negative reciprocals. 1, oh, we already did this one. I did this one up here. 1 and a negative 1. The reciprocal of 1 is 1. So the negative reciprocal would be negative 1. And this one I should have given more room. Two lines with the following slopes. In this case, you cannot take the reciprocal of 0. So, I mean, even if you wrote it as a fraction, for example, 0 over 5, that's equal to 0. But the reciprocal of this is not 5 over 0. 5 over 0 is not even a number. 0 does not have a reciprocal. So, if I want the slopes, it would be 0 and undefined. A better way to say that would have been the slope of 0 is a horizontal line. A horizontal line and a vertical line are perpendicular. Oops, jumped ahead. A horizontal line is perpendicular to a line with undefined slope. So that's saying exactly the same thing we set up here. undefined slope is here, and horizontal line has a slope of 0. Vertical line, undefined slope. Horizontal line, 0 slope. Okay, now let's write the equation of a line. Notice I said a line, any line, that is perpendicular to this guy right here. Okay, and then I'm asking how many such lines exist. Well, let's answer that first. If I take a line, say right here, I don't need an XY plane to draw a line. How many lines are perpendicular to this? Infinitely many. There's one. There's one. There's one. And actually, there's infinitely many of them between this line and this line, and between this line and this line. So to answer this one, it's infinitely many. So that's why I'm saying just write one, write a line that's perpendicular to this. Well, all we need to do here is what? What information do we need from this line? We just need the slope and nothing else. So let's write this in slope-intercept form, and that'll tell us the slope. So let's see, I could write this as 3y equals what? I'm going to subtract x from both sides and add 12 to both sides. So negative x plus 12, and then we divide everything by 3 to get y by itself. So we could write that y equals negative 1 over 3x plus 12 over 3 is 4. So this is not our answer. This line is just equivalent to this line. These two would be the same if you graphed them. So we need the equation of a line that is perpendicular to this line. And the only thing that we care about is this. The slope is negative 1/3. So for our line, what is the slope going to be? We need m equals the negative reciprocal, which would just be 3. So we could write one like y equals 3x plus 111. I just wrote that because it doesn't matter. We could have written simply y equals 3x because it has a slope of 3. Y equals 3x plus 1 has a slope of 3. Y equals 3x minus a million has a slope of 3. They're all correct answers. I asked for only one, so this one certainly works. Now let me give you a, in case you don't remember this, and I don't think I've said it before, this equation would be written in what we call the general or standard form. When you have it written in that form, even if this were written as long as you have x plus or minus, y, the x term and the y term next to each other here with plus or minus between them, the numeric part, the constant part could be here or over here, it doesn't matter. You can determine the slope of this line in a shortcut way. What is the coefficient of the x? 1. Over, what is the coefficient of the y? 3. And then throw a negative sign in front of that. That is the slope of the line when it's written in this form. So it's essentially, it just saves you a little bit of time. That's all it is. Okay, so the slope was negative 1/3. We'd already figured that out. And this line is perpendicular to this line because their slopes are negative reciprocals. And again, if you multiply negative 1/3 times 3, you get negative 1. The product of the slopes is negative 1, so they're perpendicular. All right, one more. Now, it looks like this equation is the same here that we used in the previous problem, but what are we looking for? Write the equation in general form. I rarely request that the equation be written in general form. I'm going to put general form like this. I'm going to put the C on the right-hand side. And it has to pass through this line, and be perpendicular to this. All right, so we've already done some of the work. The slope of this, we said, was negative 1/3. So we know that the slope of the line we want is m equals 3, negative reciprocal. Okay, so it's got to pass through this line, and perpendicular to this means it has a slope of 3. So this is the only information we need right here. And we'll use the point slope formula, which will tell us that y minus y1, y minus negative 6 is y plus 6 equals m, the slope, times x minus negative 2, which is x plus 2. And as I said, I prefer everybody have the answer unless the instructions state something different. I usually like to have it in y equals mx plus b or slope-intercept form, but this says write it in general form. We need to make it look like this. So we need to find a, b, and c. All right, so basically I just need to multiply this out. For starters, y plus 6 equals 3x plus 6. Well, look at that. When you subtract 6 from both sides, that 6 goes away. Now I need to subtract this from both sides because I need the x and the y on the left-hand side. Negative 3x plus y is equal to 0. And just to check how to, this is in the standard form or general form. So negative this over this. These two coefficients, negative 3 over 1. But take the opposite of that, and you get 3 over 1, which is 3. And that's exactly what we wanted. Slope of 3.